This is my code for Lab 8, navigating a Romy robot to the center of a rectangular arena that's within the max measurements of ultrasonic sensors, so 4 by 4 meters. As we go through here, many of the same magic numbers we've been using throughout the semester. I did make some, I did define the ultrasonic min and max values at 2 and 400. Distance difference, I'll go more than that in a few minutes. It's the difference in previous values and new values when the Romy robot is trying to localize itself. Let's see, distance 1, distance 2. When the Romy robot it's going to, later on in the code I'll show you that it's going to compare north and south or east and west, for example, and it will basically declare those as distance 1 and distance 2. Let's see, we have previous distance and new distance. That's a way for the Romy robot to compare new values to previous values in one of the arrays coming up, and I'll go more into that in a second. My array size, this actually is from, my array size is from previous lab where we're using a bubble sort, except in that lab I believe I just did 5 for my 5 values in my array, then take the median. However, when the Romy robot is making its turns and trying to get perpendicular to a wall, I need to make sure I have be as accurate as possible. Therefore, I needed more values. Also, I have another array here. Again, I was getting some erratic values and read online that using a moving average array is a good way to help with the ultrasonic sensor readings. So I found this example online. It's implementation of moving average in Arduino. Modified it a bit so it would work in my code. And I'll go more to that in a few minutes here. That array size will be 10. The large array size does slow down the Romy robot some, but again, it's helping with accuracy, which I'll sacrifice that in this lab, accuracy for time. Here we go into the loop. Of course, we do nothing until this button is pressed. Then we make sure the red LED is off. Once 2 seconds is up, we start to localize. We call the localize function. So in the localize function, it gets its new distance from the moving average, and here we have the moving average here, which I alluded to earlier. And what it's doing, and it's setting so the new distance is going to be getting from the moving average. The previous distance, the first value, I'm just setting to the ultrasonic max value of 400. So basically this thing, this Romy robot is going to just turn to the left 1 degree. As I said earlier, it's because we don't know what position, the initial position the Romy robot will be placed in. So it needs to keep moving until it's perpendicular to the wall. To do that, it will keep turning until this is satisfied. So basically, if the new distance is greater than the previous distance, plus a little buffer I threw in there, and I noted it earlier, I believe it's 0.01 at the moment, and if the absolute value of the new distance minus the previous distance is greater than this distance difference, which I define as a magic number, it's very low, it's 0.02, but I found out at the beginning I would get some values that might be 400 and the next value may be 10, and I just know something's way off. So the values need to be valid, they need to be close to each other. So once all these are met, we will stop the motors. Let's see, we don't need the serial print. Let me get rid of that. I used that during my debugging stage. So once that is satisfied, it stops moving. When this happens, it will stop when it is perpendicular to the wall, and that's basically because the new distance and the previous distance values are very similar at that point. So the new distance was decreasing until it starts to increase again. And at that point, I know it's perpendicular to the wall. So once that happens, I am perpendicular to the wall, as I said, so we will turn the Roaming robot 90 degrees. So this can now be either facing north or south, whatever we designate it at, doesn't really matter. After that, yeah, it's just the angle turn. It says angle turn to 90. I'll go down and explain that real quick. Void, here we are, void angle turn left, I believe that's what it was. So we take the angle that we had as a 90, and that's going to be, it's a function of that angle. We also have a count for distance. Actually, it's count for turn, which is a that's going to take in certain parameters like wheel diameter, count per revolution, the turn angle, and the base of the Roaming robot, which is 14 centimeters. And we know the calculations here. We've been using them throughout the semester. And that's what we'll get for the pulses for the angle. Let's see. Once we do the angle turn, we'll do, I call it scan and rotate. So this doesn't really matter if it's east, west, or north or south, but it calls the scan and rotate function. Scan and rotate function, for example, it is now parallel to its initial, the wall that it was perpendicular with and is now parallel. So now it's facing two distances. We'll just call it north and south. North can be distance 1, south can be distance 2. So it will look at that and it will compare the distance. So it'll look forward, call it north, it'll get that distance. It'll then rotate 180 degrees and get that distance. It'll make a comparison to see which one is greater. So if the initial one is greater, it will turn back to that angle, or if the new angle is greater, it'll just stay where it's at. It will know it needs to take the difference between the two distances divided by 2, and that's the distance it needs to travel. And that will be called in our drive straight function. We've been using this throughout semester, but in the last lab, I was able to add this adjust parameter, which makes it drive straighter instead of incrementing all the way up to 255 or all the way down to 30. It would, now it just does it by just increment or decrement by 10, and it's a smoother transition. And I did something similar for that in the angle turn left. We have an adjust here as well. So once that happens, it determines which distance is longer and how much it needs to travel. We will go to that, and then it will, once it gets there, it will stop. And we'll go back up to our angle. Once it gets there, it will stop and do a angle turn left again. So this way, now it's in the middle, but it's facing, we'll say, east and west at this point. So we'll do something very similar. It will find out, it'll call the scan and rotate function to see which distance is longer, and it will travel in the difference of the east and west and divide by 2, and to get to where it needs to go, to put it in the center. And at that point, it should be in the center of the arena. So it will stop, and the red LED will come on, and the red LED will stay on until the button is pressed again. Some other things we can look at real quick. We have, again, we have the get distance, and the get distance again, there's a lot of erratic readings coming from the ultrasonic sensor. So first thing we'll do is take a bubble sort, and then we'll take the bubble sort array, and then we'll take the median of that, as we did in the last lab, maybe last 2 labs. Then we will make sure that the values, and we'll take the median of that, and then to make sure that these values are valid, they'll go through another filter here with the Ultramin and the Ultramax. This is just to make sure it's between 2 and 400, and it will return that value. to whatever we need it, like the ultrasonic sensor when it needs to pull a reading. So basically we have some various sets of arrays in here. Most notably, there's the medium array, there is the moving average array that I mentioned earlier, and then there's this filter to make sure the value is between 2 and 400. And I increase the array size to, I believe it said 19 when I'm trying to turn that angle. Okay, so here's the Romy robot. We will upload the code. And give it a second here. Okay, we are done uploading. So I'll take you over to the arena. So this arena is a box. Its dimensions of approximately 31 inches, which you can see here. Well, maybe right there, 31 inches. It's hard to see from here. We have a couple rulers here, but 31 inches by 20.5 inches, which is roughly, according to this, 78.74 times 52.07 centimeters. So I'm going to set up real quick. Let's see, position this camera here for initial setup. Explain something real quick. So what we have here, this is an angle measure, an angle ruler. I have it set for 45 degrees. So I will take this robot. Let's see, make sure it's kind of at a 45-degree angle from the wall, which appears to be there. We also know that the Romy robot can be anywhere from 8 to 10 centimeters from the wall. So I think I'll just put it at 9. That's about right. So I will start a battery for the weight. Cut it on. Let's see here. And what I'll do, stand above it, but hit the button. It'll wait 2 seconds, and then it'll very slowly start to turn. Again, it's a huge array that's happening, so it's affecting the speed. So I have to have a time limit, so therefore I erred on the side of precision as opposed to time. So you can see it's measuring the angles. Every 1 degree it's taking a measurement. So right now it's doing the localization function, just trying to get perpendicular to the wall. Again, it's comparing the ultrasonic values, the previous versus the new. As the new starts to decrease, and then suddenly it will increase, and it knows it's there. So it knows its purpose. So now it's turning north and south. So it just made its 9-degree turn, and what it's doing now is it went north and south comparing. So that, we'll just say that was north, and then we can say this is south. It's going to see that south is greater, so it's going to go half that distance, stop, and then it's going to compare, we'll say east and west at that point. And we'll say west is longer, so it's going to go back, travel half the distance between the two, and then stop. So stop there. Fairly good. Pretty good. Looks like it's could be 1 degree off, but overall it's at least in this smaller arena it did fairly well. Hopefully in what other testing environment it will do well again. So that's it. I was pleased with this result. I tried other angles and this had a pretty good success rate.